In this video, we have 4 different tables of values for variables x and y. We're asked to identify a pattern, in other words, a relationship between x and y for each of them. In these examples, we will simply look at patterns between x and y. As we continue studying linear equations in two variables, we'll develop a formal method for identifying linear relationships between x and y. So I have the first two tables shown here. We have table A and table B. Let's look at table A, and I have two columns, one labeled with x and one labeled with y. And in the x column, I see that I have -2, -1, 0, 1, 2, and 3. So these are each going up by 1 unit, and they're going up consistently. They all go up by 1. So I'm going to just note that there's a +1 as I move from one x value to the next. As I look in that y column, I see that I have the values -8, -4, 0, 4, 8, and 12. So the first thing that I can note is that these are multiples of 4. And each one just goes up by 4 units. So they go +4, +4, +4 each time. And so if I'm looking at that relationship then, the key here is that since these are each multiples of 4, so let's look at the relationship between the x value of 3 and the y value of 12. I take 3, I multiply by 4, I get 12. And I could go up to the x value of 2. I take 2, I multiply by 4, I get 8. And that pattern is going to work for each of these, even for this x value of 0 and this y value of 0. I take 0 times 4, I still get 0. -1 times 4, I'm going to get that -4. And so for each of those, I'm taking the x value and multiplying it by 4. And so the way that I would represent that pattern is that y is 4 times x. So I'd write that relationship as y equals 4x. Now if we come over to table B, I can see that again I have the x values of -2, -1, 0, 1, 2, and 3. And so I can note that those are each going up by +1. The y values in this example, though, are going to be a little bit different. I see that I have -7, -3, 1, 5, 9, and 13. And those are not immediately multiples of any specific number. But if I look at them, to get from -7 to -3, those y values are going up by 4. And then -3 to 1, they're going up by 4 again. And we see that again, and we see that in each example. So as we look at that pattern, and we look at those relationships, I noted before that each of my y values went up by 4, and I had 4x. Here, if I were to take 3, for example, and multiply by 4, I'd get 12, but then I've got to have one more unit to get to 13. And if I try that again, 2 times 4, and then add one more, I'll get 9. And so I'm seeing that the y value is 4 times the x value, but with one additional number added. So I can write that relationship as y equals 4x plus 1. Let's now continue on to our next two examples, where we have table C and table D. In table C, these x values are a little bit different. So instead of having -2 through 3 like I have in the last couple of examples, I have -200, -100, 0, 100, 200, and 300 in that table. Then if I look at the y column, I have -20, -10, 0, 10, 20, and 30. And if I look at this, I could look at the differences between them. That would be one option. But I should be able to see a pattern pretty quickly. 300 to get to 30, 200 get to 20. Those y values are all 1/10 of those x values. And so the way that I can represent that relationship is that y equals 1/10 x. Our last example is going to be a little bit different. I can see these x values of -2, -1, 0, 1, 2, and 3. But then my y values don't follow a pattern where they don't look like multiples of my x values. I can see that they are not. And they're not changing by the same number. If I look at going from 4 to 1, I've gone down 3. And from 1 to 0, down 1, but now back up to 1. So now I've got +1 to go from 0 to 1. And that would continue to +3, and then +5. So something else is going on. So if I look at these, 4, 1, 0, 1, 4, and 9, one thing that I'm going to note is that these are perfect squares. And again, at this point, we're just looking for patterns. So I deduced that they were not multiples of those x values, but they are perfect squares. And so if I look at that relationship then between x and y, getting from 3 to 9, it's squared. And from 2 to 4, again, that's going to be squared. And this same pattern will continue. 1 squared will give me 1, 0 squared will give me 0. And then -1, if I square that, does indeed give me +1, so that pattern still fits. And then -2, if I square that, I'll get +4. So I can see then that my y value is that x value squared, and so I'd write that relationship as y equals x squared.